Imagine if you could change the acoustics of a room just by the push of a button. It sounds interesting, doesn't it? Fabio Kaiser will be our next speaker. He has come all the way from Austria. He is the CEO of Amadeus Acoustics. Please, everybody, give Fabio a very warm welcome.
Thank you. 1, 2, 1, 2, 1, 2. Check, check. Thanks a lot. Thanks for the invitation. It's an honor to speak here, and I think we can have a nice transition from the last talk to this talk. But let me ask you first, how did you like the choir concert yesterday? Who liked the choir concert? Okay. I personally really enjoyed it. It's actually funny because I do sing in a choir, and I had rehearsal yesterday. So I missed it, but I had kind of a bit of a practice. So it was quite nice. I really enjoyed it, but to be honest, there was one element missing for me. What could that be? Reverberation. This room here is perfect, has perfect acoustics for amplified speech. We experienced this the last two days. Works quite nice. But when they started singing, I was missing something. Where's this? Yeah. So when I judge the sound quality of a situation or acoustic quality in general, I like to go back to that simple model you see here. I like to judge the quality of the direct sound, the background sounds, and reverberation, of course. So direct sound, the choir singers did a really good job. The music, their musicality, dynamics, intonality was really fine. Background noise was quiet, good, but the reverberation was definitely missing for a pleasing musical experience. Now, as acoustic designers, is to take care of background sound, find an optimal solution for background sound and reverberation. Now, we experienced the use of a space can change, so the requirements inside the same space can change, like we just heard in the previous presentation. Now, wouldn't it be great to have a tool we can take full control for any situation at the push of a button? And we can create different soundscapes or background sounds in general, and we can create different reverberation situations. This is what we're going to talk about. This is what active acoustics or room acoustic enhancement is about, and this is what 3D sound is about. So a little bit about Amadeus Acoustics, founded in 2018. We're based in Vienna, Austria, and the mission is quite simple. We shape sound. We set the stage for good performances and for the people using the spaces. And you can see my partners, Thorsten Rode, our senior acoustician, Volko Werner, he's the CTO, and the guy with the golden ears. And me, it's the engineer turning into a business guy now. So yeah, quite a transition. And we started out some 10 years ago, actually, when this cellist came to us and he asked, guys, I want to do an open air concert, but it should sound like in a concert hall. And I was just coming out of university, did some research on those things, and I said, okay, I think we can do something like this. A few months later, we're standing in Sevilla, and we were giving the opportunity to experiment for 2 weeks, actually. Somebody paid for that. And we were, like this is my colleague Volker and me, in a quite casual way, as you can see, we were experimenting, developing the basic technology and testing the first prototypes. And some 8 years later, we are standing in a concert hall like this, and we are able to work with one of the best acoustic consulting offices and the best orchestras in the world, like Berlin Philharmonic Orchestra or European Chamber Orchestra. Quite a rewarding journey it has been already, but it's been like this because there's a demand, the multi-purpose demand. So let's take a look at a typical small theater. This is a theater in the east of Germany, Bad Elster at the Czech border. It hosts around 300 people. And let's take a look at the program. What do they need to do? Like on the left upper corner, it was in the 4th of December, there was a comedy show. 1 day later, it's a musical. 2 weeks later, it's a piano concert and then a symphony concert. So how should such a small little theater host such a variety of events? And for those of you who say now, yeah, of course, it's a small space, it's always been like this. Let's take a look at a bigger hall. Who knows? The Hamburg Elbphilharmonie 2016, it was quite prominent in the news, not only because of costs, also because of the acoustics. And let's take a look at the program here. I think we all agree this is a typical concert hall. So top you see a small Baroque orchestra playing Bach, then Prokofiev, Stravinsky, the big symphony orchestra, and then a few days later, Tricky, a trip-hop artist from the UK, definitely amplified music. So even this concert hall, great, big, huge project needs to host this variety of events. And how did they actually solve it? Curtains, like we heard before. For those who don't know, this inner wall cladding, they call it the white skin. It's quite unique and I really like it. It's beautiful. Cost around 10 million euros just by itself. We could have built a whole new concert hall with that money, but that's just the inner white skin. And what do? They put curtains in front of it. So it's hidden. It changes the aesthetics. And then, of course, curtain systems have maintenance issues, and they also cost quite some money. So there's another approach, and we call it the active acoustic approach, which, for those who don't know, how does it work? You put microphones inside the space and loudspeakers on walls and ceilings, and you have a signal processing unit connecting microphones and loudspeakers. The microphones pick up sound. The signal processor is adding reflections and reverb, and the loudspeakers are playing back those reflections. And the result is that you can change the acoustics and influence the reverberation, the acoustic response. So if we would take that hall and we would improve it to be more variable, I don't know, we would install something like 16 to 20 microphones hanging from the ceiling and something like 40 loudspeakers on walls and ceiling. Rough calculation, just so you have a feeling. And is this actually used in the real world? Yes, it is. Théâtre de Beaulieu in Lausanne, Andermatt Concert Hall also in Switzerland. This is this little theater in the east of Germany. Then a Congress Center in Alpbach in the mountains, in Austrian mountains. Hanover Congress Center, the biggest concert hall in Germany. And Congress Center in Suhl. We're going to hear more about that. 1,500 people. All of those spaces have the same problem, multi-purpose. So how should we deal with acoustics? And they took the answer of the active acoustic approach. The signal processing is, of course, a digital signal processing. It's software running, and that's why we talk about the digitization of room acoustics, because we use this digital tool. Okay, so this is my colleague Torsten. I just want to give you, with that little video, I hope it works. There will be sound coming. He will scream his acoustic test signal into the room, and you're gonna hear 3 different settings, which are switched just with a push of a button. So beware, I hope it works. Thank you, Torsten. Amazing demonstration. I hope you could hear at least the last setting was kind of a cathedral style sound. This was filmed just with my mobile phone, and it was an art installation in Basel, a quite small room, I think something like 60 square meters, and a video artist worked with our system there. So I think you get an idea of what this actually is, and yes, we can enhance reverb. So this is the Congress Center in Seoul, 1,500 people. It's quite dry, and the typical application is rock and pop concerts. But twice a month there is a symphony orchestra coming to play. And you see the measurements of reverberation times in mid frequencies without any enhancement, it's 1.5 seconds. And then those systems are usually tuned to have different presets, different settings, and the reverberation times can go up from 1.7 seconds, 1.8, 2.2 seconds, and we can even go up to 3.5 to 4 seconds to have this cathedral-like effect. So as an acoustician, I'm partly happy already. Reverb is one of the main parameters we want to influence, but of course, we want to be able to do more. So can we do more? We were talking about different measures already. And we did a little experiment. What we wanted to show and do is that we can actually have two settings of the system, having same reverberation times, but a very different sense of clarity, a different transparency. We did that, and you can see the measurements of center time. Thanks for the speaker before, who also agreed on that center time is probably even, maybe a little bit a better measure for clarity and transparency. And yeah, we did this experiment, two different settings, having same reverberation time, but a difference in center time of 50 milliseconds. And on the right side, you see I put the just noticeable differences, which are according to the standard around 10 milliseconds. So this is a significant change, and I can assure you the sound there was really different, a total different experience of the acoustics in that space. So yes, we can do more. The question is, can we do even more? Yes, we can. 3D sound, immersive audio, 3D audio, spatial sound, whatever you want to call it. We do have a lot of loudspeakers installed, and of course we developed a algorithm to place sound sources around the space in 3D space, so you can create soundscapes that have an immersion that can create a very natural soundscape. This is just a little picture to show what this means. And yes, this is also installed. House of Digitization in Austria. This is a Mozart experience in the middle of Vienna. You really should go there if you visit Vienna. This is a James Bond experience in the Tyrolean mountains in Austria. This is an open-air opera. They used sound effects, spatial sound effects in the opera. And this is an art installation in the south of France, Luma in Arles. And this is also an art installation in Basel, in Switzerland. So also such a system is used, and we're discussing a lot in our office, like how should we call this process? Active acoustics, spatial sound, immersive audio. There's all these terms out there. So we came up with a new term, immersive acoustics. It's the combination of 3D sound and active acoustics. Please tell me if you like that term. We introduced it now, but it's important to understand that there is a new feature in that. If you're sitting in the cinema, you can have a quite high feeling of immersion. The story, the sounds. But when you clap, you're not part of the action. So you're not part. The sounds are, you have an emission, sound emission, but you cannot excite the acoustics, because in the cinema it's usually dry. Having a 3D sound system running in parallel with an active acoustic system allows people to be inside the scene, be inside the story, have an interactive acoustic feeling. So you clap and you are in the same acoustic space like the sounds are. This is why we thought, let's call it immersive acoustics, and it gives full control over the acoustic experience of any space. So I'm telling now any space. For now, till now, I was talking about performance spaces, shows, experiences, but what actually about more ordinary rooms, like offices, restaurants, cafes, gyms, fitness studios, spa, wellness, retail stores, or hospitals? I'm gonna just throw in some ideas now. I'm thinking out loud now. Let's go back to that model. In all those, thanks, in all those spaces, we don't want to control the direct sound. Obviously, we want to have direct sound over short distances, but we're going to control background sound, that's for sure. And why not control reverberation too? Like in an office space, we bring down reverberation, and then sometimes we bring up the background noise level through sound masking. First idea, why does it just have to be noise? It can be a soundscape, can be a designed experience. And second thought, why not introduce a little bit of more reverberation to have variable reverberation to actually influence the effect of the environment on people. Restaurant cafes, when it's getting later, the restaurant owners usually turn up the music a little bit. You could also turn up the reverberation to change the atmospheres. And so on. Retail stores, hospitals. In hospitals, maybe it's interesting, especially in the US, they start to use a lot of soundscape designs and spatial audio systems to support people to get healthier quicker. So immersive acoustics is a tool to design and provide any acoustic experience desired in any space at the push of a button. And I think there's two main challenges we have in ordinary spaces. Of course, it's budget. We can be happy if we can introduce echophone panels and bring down reverberation. Now this guy wants to bring in an electronic system to bring it up again. This is extra cost, of course, but it adds extra value. And for some projects and applications, it's maybe also in ordinary rooms worth it. And the second question is the control. Who decides what reverberation is the best for a given situation in the moment? But this is a challenge, but can be an opportunity too, because suddenly we can design the acoustics after construction. We do not only have to work before, we can work after construction. We can go there, talk to people, what do you like and what do you not like, and we can start designing the acoustics after installation. We're running experiments in our own office. This is in Vienna. Feel free to visit us. And we're gonna have some results hopefully soon. If you're interested to get some more information, there's a QR code pointing to a webinar, free webinar, where you get some more information. Thank you.
Thank you very much, Fabio. That was really, really interesting.